Hello, pre-calculus again. It is time for section 4, inverse functions and relations. We're going to try this a different way. Two functions are inverses. So the inverse, an inverse relation. If AB is on the graph of the original function, then BA is on the graph of the inverse relation. If an inverse passes, let me try that again. If a function passes the horizontal line test, then its inverse will pass the vertical line test and be a function. Two functions are inverses if and only if composing them undoes they undo each other and leave you with the original input. Nutaya says that the inverse of 3 plus or minus the square root of x plus 2 cannot be a function because 3 plus or minus the square root of x plus 2 is not a function. Is she right? Well, we can look at this two ways. We can look at it in terms of graphing, or we can look at it algebraically. We'll do graphing first. 3 plus or minus x square root 2 is going to look like, roughly like this. That would be 3 plus square root of x plus 2. This would be 3 minus square root of x plus 2. Remember, the 3 is going to move it up 3. The x plus 2 will move it to the left 2. So that's what the function would look like. Now the inverse of this function would be a different relation. Actually, I'm sorry, this is not a function. She's right that this is not a function. But this would pass the horizontal line test, and therefore if you inverted it, it would pass the vertical line test. So, if you, I'm not actually sure that I can do the inversion, but, yeah, no, that doesn't work. So the inverse, if we go over, reflect it over the y equals x line, the inverse would be more like this. Let's see. So if this is, say, -2, +3, +3, -2. If this is at something like 0, 2, let's be at something like 2, 0. And it'll go like this. So it looks to me like this is a function. Let's check that algebraically. So the original is 3 plus or minus square root of x plus 2. In order to invert it, first we swap our x and y. So x equals 3 plus or minus the square root of x plus 2. Oops, sorry, y plus 2, because we're inverting. Then we're going to solve this to get y by itself. So the first thing we need to do is subtract 3 from both sides. So x minus 3 equals plus or minus the square root of y plus 2. The next step is to square essentially the entire thing, right? We're going to square this side, and whether it's positive or negative won't matter, because when you square it, it will end up positive. So we square this side, and anything you do to one side, you have to do to the other. So over here we've got x minus 3 squared. So x minus 3 squared equals plus or minus square root of y plus 2 squared. I am going to, for the time being, leave this side just as x minus 3 squared. And it doesn't need to be, we can of course FOIL it out, but I'm not going to just yet. However, over here, what's going to happen? Well, both the positive and the negative, when you square them, will become positive, so that won't matter anymore. And squaring and taking the square root will undo each other. So what's on this side is just y plus 2. So the last step, then, would be to subtract 2 from both sides. So we get x minus 3 squared minus 2 equals y. Is that a function? Yeah, it's a function. And it would look like this. Well, yeah, it would look roughly, if I could draw, it would look like this. And that is a function, so she is incorrect. So even if the original is not a function, the inverse may be. Now for part 2, first we're going to graph the function and then its inverse. To graph the function, we have absolute value of x plus 1. The function absolute value of x is a v centering at the origin. This plus 1 after the function means that it will go up 1. So now the center point will be here, and it goes up 1 over 1, up 1 over 1, up 1 over 1, and then on the other side, up 1 backwards 1, up 1 backwards 1, up 1 backwards 1. So there we go. There is absolute value of x plus 1. Now, to graph the inverse, I'm going to do this both, graphically for this kind of function, for an absolute value function, is actually easier. So I'm going to draw this diagonal. This is the line y equals x, and the inverse of a function is its reflection across this line. So if the center point of this is at 0, 1, and it is, so let's say 0, 1 is the center point here, then the center point for its inverse will be at 1, 0. It's going to have a center point right here. Sorry. I'm sure you all knew something was going wrong there. I wrote the right thing but drew the wrong dot, so it's at 1, 0, which is actually here. I'm not quite sure what happened to me there. Alright, if the graph goes through 1, 2, then the inverse graph goes through 2, 1. 3, 4, 4, 3, etc. Now on the other hand, if it goes through negative 1, positive 2, then the inverse goes through positive 2, negative 1, and so on and so forth. So you can sketch the graph of it. Sometimes you can do it directly, and sometimes you really need to sketch a couple points first, but it's always very easy. If you can find some points, you swap the x and y and graph those. So this is the inverse. Now for x cubed plus 1, I'm going to do this both graphically and algebraically. The graph of x cubed is this one that I've shown you a couple times. This moves it up 1, so now it's going to go, nope, sorry. It's going to go, this is really hard on the computer. Basically, it's going to go through here, go up, and down, because once again, that plus 1 moves it up 1. So graphically, what we can do, draw our y equals x line. If this goes through 0, 1, again, the inverse will go through 1, 0. This one goes through 1, 2. This will go through 2, 1. This goes through 2, 9. This one will go through 9, 2. So it'll go like this. And going the other direction, this goes through negative 1, 0. This will go through 0, negative 1. And the rest of it goes more like this. So there's the inverse, and you should be able to see how they are reflections of each other. Algebraically, if you have y equals x cubed, I'm doing that to save myself time, plus 1, swap your x and y. First thing we'll need to do is subtract 1 from both sides, so x minus 1 equals y cubed. And then we'll take the cube root. So we're going to do cube root of x minus 1 equals y. And this is the graph of cube root of x minus 1, and you can check that in your calculator. So this should be the inverse. Now this one, negative x minus 3 squared plus 1. Please don't draw yet. I'm going to draw it and then move it around some before I want you to draw it. So we're going to start with the graph of x cubed. And then we're going to talk about, what happens to it as we shift it around. So there's the graph of x cubed. This minus 3 shifts it to the right 3. This negative flips it upside down, so can I do that? I think I can. Aha, flip up down. It's still centered at that point, but now it's pointing downward. And then it is moved up by 1. So here, then, is this graph. The center is at 3, 1, and it's pointing downward. The inverse then, graphically, do your y equals x line, pick some points. I said 3, 1, well then the other one is at 1, 3. Make it purple. This crosses at 2, 0, then this will cross at 0, 2. This crosses at 4, 0, then this will cross at 0, 4. And it'll go more or less like this. If you're any better at drawing, please do be better at drawing than I am. I'm terrible at drawing. Oops, let's go ahead and invert it algebraically. There is one thing you've got to be careful about when you're doing this. So the first thing we're going to do, swap our y and x. So now it's going to be x equals negative y minus 3 squared plus 1. Subtract 1 from both sides. Great. X minus 1 equals negative y minus 3 squared. Now, multiply or divide by negative 1. So this side will become negative x plus 1. Ugh, gosh, sorry about that. Negative x plus 1 equals y minus 3 squared. Got rid of the negative here. Now we need to take the square root. Here's the thing you got to be careful of. Anytime you're taking the square root, you're going to need to do plus or minus. So, plus or minus, oops, the square root of, and once again this is elevated. Okay, plus or minus the square root of negative x plus 1, or 1 minus x if you like, equals y minus 3 squared. Finally, add that 3 to both sides, you get positive 3 plus or minus square root of negative x plus 1 equals y, which is what this is. So this is 3 plus or minus the square root of x plus 1. Uh-oh. Okay, last piece of this. We're going to find the inverse, and we're going to state whether it's a function. So, to find the inverse, you swap your x and y. So instead of, well, f of x here, we're going to use y for. So we're going to put x where this would be and y where that would be. So x equals negative 3y plus 2. And then you solve for y the way you normally would. Subtract 2 first. X minus 2 equals negative 3y. Oops. And then divide by negative 3. So that'll be negative x over 3 plus 2/3. Don't forget about don't forget to divide both of them by the negative. That's what I'm trying to say. So there is my inverse, my f inverse of x. And we can now replace the y with f inverse of x. And then to tell whether it's a function, well, you can graph it and look at it, or you could just look at this. This is going to be a function. This is linear. It's not an x equals line. This would be a line with a y-intercept of 2/3 and a slope of negative 1/3. This is completely a function. For part B, x equals 1 over y cubed. Sorry, it's harder to do powers here than you'd think. So, x equals 1 over y cubed. The next thing to do, and I know this is a little weird, but when the variable's on the bottom, we want to get it out of there by multiplying. So we multiply both sides by y cubed. We get x times y cubed equals 1. And then we can divide by x. So, dividing both sides by x gives us y cubed equals 1 over x. Finally, we'll take the cube root. Y equals the cube root of 1 over x. Maybe put that in parentheses. 1 over x. Which is the same as 1 over the cube root of x if you like. Now, notice I didn't put a plus or minus here. You only put a plus or minus here when it's an even root. Since this is an odd root, I don't need to do it. If x is negative, this will be negative. If x is positive, this will be positive. So we've got y equals the cube root of 1 over x. Cube roots, odd roots, are functions. If you graph this original one, it would pass the horizontal line test, so this will pass the vertical line test. Yes, this is a function. F of x equals x plus 2 squared plus 6. Swap the x and y. X equals, you know what? Why don't I copy and paste instead of reinventing the wheel every time? So x equals y plus 2 squared plus 6. Subtract the 6. X minus 6 equals, y plus 2. Sorry about that. Y plus 2 squared. Now, we need to take the square root of both sides, right? That's not what I wanted to do. That's better. Okay, so we're going to take the square root of both sides. It's an even root. An even root means you have to remember to do plus or minus square root. So plus or minus the square root of x minus 6. That'll get rid of this. One step left, and that is to subtract the 2 from both sides. And the easiest way to write the result is to put it in front. So positive 2 plus or minus square root of x minus 6. Now this plus or minus, that's a very important key. That means it's not going to be a function, because this is going to be one of these guys that goes this way and this way. That's what the plus or minus does. This does not pass the horizontal line test, so this does not pass the vertical line test. Therefore, the answer is no. It is not a function. Last thing is verifying, and yes, if I say verify that they are inverses, you do have to do this. So, first we're finding the inverse. X equals 1/2 y minus 5. Add 5 to both sides. X plus 5 equals 1/2 y, half y. And then you can think of the next step as multiplying by 2 or dividing by 1/2, but they do the same thing. So 2x plus 10 equals y. So that's our f inverse. 2x plus 10 equals f inverse of x. Notice this inverse, it's the same thing we used for inverse for matrices. That's y, because that means inverse. Now, to verify, we need to compose. So we need to do f composed with f inverse of x. And then we will also need to do, again, why don't I copy this? We will also need to do f inverse composed with f of x. That is, putting the f inverse inside and then putting the f inverse outside. Both of them have to come out with x. If they don't, they're not inverses. So basically what we're seeing is whether or not our end result is x. That is, does f undo f inverse? Does f inverse undo f and give you back whatever you put in? So let's find out. Remember to do your composition. You write your exterior function 1/2 x minus 5 with a big blank where the x is. And then in that big blank, let's do this so you can see it a little better. In this big blank, you put your inner function, 2x plus 10. So f of x is on the outside, f of inverse of x is on the inside. Well, let's distribute that 1/2. 1/2 times 2 is 1, so that just becomes 1x. 1/2 times 10 is 5. X plus 5 minus 5. Does that equal x? Yes, it does. Remember, you got to check it both ways, though. So now our outside function is the f inverse. So it's 2, great big blank, plus 10. And our inside function now is the f, blue, I think. 1/2 x minus 5. Minus 5? Yes, minus 5. So, that means, well, 2 times 1/2 is 1, so 1x minus 2 times 5 is 10. X minus 10 plus 10, those add up to 0, it equals x. So what we have proven is that, yes, f and f inverse are inverses, but you have to prove it by composing them with each other. That's it. Sorry it took so long. Doing it this new way may not be ideal. I'm still fiddling with it. See you soon.